Good afternoon. I'm Philip Lagonilla from Advanced Energy, one of the design managers, and the topic was for research and development of what are we doing. We're basically a power supply or power conversion company, designing power conversion products and manufacturing them. So for this afternoon, we're gonna talk about some introduction about AEI or advanced energy. We're gonna talk about the drivers that drives our R&D, what is the technology trends and what is required in the market. You're going to see how we develop power supplies. So we're not just in the designing of power supplies, so it's not just barely the design, but the total package of it. Also, we have this safety and reliability. We'll touch base on that. A little bit of our facilities in our markets, and then we'll show you a video. You may be seeing it in the ads, but it's basically a video of a summary of what we're doing in AEI, as engineers. Okay. Okay, straight from the internet. This is the AEI fact sheet. Basically, the highlight here is that advanced energy, we design and manufacture power conversion and measurement and control solutions. Okay, for our customers. So this is the core of what we do. But then again, when we say power supplies, let's say we were located in Eastwood. So anong ginagawa nyo? We're designing power supplies. Saan kayo? Eastwood. Ano kayo? Like a call center. So hindi nila malaman ano yung power supply. Ano ba yung power supply? One thing comes to mind pag sinabing power supply is this. It's the old school power supply. Actually, the power supply ng mga PCs ngayon are more aesthetic. They have good colors, modularized. But this is ang tingin nila sa power supplies. But actually, power supplies is more than meets the eye. All right. We cater to these industries: semiconductor, industrial, data center, telecom, and networking. So this is the base ng mga customers namin. So the power supplies really, old school. They are what do we call that? Unnecessary evil. No? So we were reviewing the slides. It's a necessary evil. While kailangan lang siya. Nothing is really being powered kung walang power supply. Okay? But right now, it's now getting technology-driven. Meron na siyang aesthetics. So nakikita natin siya in our chargers. The EVs, they look good. They're now exposed. They're also used in different applications like horticulture. So there's a different drive now on power supplies. But dati, sila yung mga nakatago. They're always embedded. We're always third-class citizens. And so, of course, that's being challenged with that is that we now design according to the space that was given to us, and we think about the technologies we put to deliver value dun sa customers namin. Okay, so for R&D, this is ilan lang naman R&D sa Philippines, no? But we're really R&D. We're coming into different markets. We do AC, DC, and DC-DC converters. We do chargers. We do inverters. And here, I already talked about the markets, but there are key drivers here that keeps us on our toes when we design power supply. So they are the conversion efficiencies, power density, how much you can pack sa isang size and get big power, thermal management, scale, and of course cost. Okay, so it's about basically it's about the triangle that it's coming around. It's not entirely new, but this is the challenge of the design. So one is density and efficiency. So there's always continuous research to be efficient. Customers want it efficient. For the server platforms, they want it they say more than 95, 96, 97, going to 98% efficiencies. And it's because I think the theme natin is sustainability. So we also contribute to that by delivering highly efficient power supplies. We contribute also to the world in terms of power conversion and electricity cost. Okay, so pa-compact ng pa-compact, and then they want it really all efficient. Next drivers, we give value add. So we are we do creative and intelligent ways implementing new features, and so in terms of packaging, we use digital control now by using DSPs, and then we work with our customers closely by doing systems integration. So for packaging, really, for example, I work, one of my projects are more of telecom, They're really, we are really considered as like second to third class citizens there. So they designed their all 5G radio. Then we see the 5G radio, it's good, high tech, and then the space for the power supply is so odd shaped. And then meron mga requirements sila, specifications, that we are to design in that odd shaped and still meeting yung mga dinideliver namin value. So one of the challenge there. And of course, cost. So we have to maintain cost competitiveness. And we do, our own proprietary measures. We do modularization. We design for automation also. Because even with the new technologies being discussed, it's still sometimes boiling down to the cost, especially if the customer, is not willing to pay for it. So kahit na you have new technologies, you have GaN, you have silicon carbides, but they cannot pay. So, okay. So that limits, and that's also one of our challenges. Okay. So trends is, the market is really going for low cost, the high efficiency, density, and scalability. So magka-contrast eh. They all want highly efficient. They all want compactness, and yet they all want it also at low cost. So those are really the three challenges that we're working on in advanced energy. So mahirap yun. It's not as linear. So if you also want value, that may value rin siya in terms of cost. Okay. For industrial power, we're working on three-phase power. We're trying to increase the power and power density. We're doing configuration and getting them modular. Also, we're looking into different cooling techniques because yung iba dyan, like servers are all fan cooled. For the telecom, they are conduction cooled, so they are really fanless. And then they want it, like 10 years life because our customers probably is based in Europe. Pag nag-conk out yung 5G radio, no one's gonna go there sa tower, di ba? So power supplies need to be reliable. So okay, so different cooling, conduction cooled. Okay, so for the open compute. We're working with industry partners. Again, the numbers here is more of efficiency. Okay. And those are the things that in the last bullet is keeping us in our toes in terms of R&D. Okay, so our focus is, again, driving for high efficiency. We do that by using high performance devices. That's silicon carbide or GaN. We optimize our magnetics design, so we use our simulation. We drive for low core losses, and we use simulation also so that we would know the core losses, the flux density even before we build them. For power density, and there are always form factor challenges like what I shared about in telecom. We're third-class citizen. It's not really a square or rectangle they give us. They give us semicircles in between. And then yung mounting pa ng radio nila, nasa smack in the middle of our power supply. So it is a challenge. But we're steadily increasing. So we're now, for greater than 60 watt per cubic inch for the 1U profiles. We're trying to get greater than 30 watts for three-phase power and 800 watts ito for board-mounted bricks. Again, thermal challenges here. So we use in our simulation flow therm. For performance, we use proprietary solutions. We're just trying to not go into the details of this one, but in R&D we try to think of ways to give solutions to the customers. At the same time, since they're proprietary, we also get to invent things, patent things. So these are just the things we do for our customers. Okay, so how do you design a power supply? You start by doing simulation. We have simulation tools, so the more tools, the more fun. It's because even before you build the power supply, you already get to see the performance. So we simulate them block by block. We use some of the common, sometimes in the industry, MathCAD, the symmetrics, and we're able to see actually through our flow therm component temperatures. Okay? So before we even move to building yung actual power supply. So even before it's a trial and error na makita namin na it's gonna be, hot. Then we are able now to simulate that. And even in the PCB, we're trying to, we can check, the balancing of loops, and we have our best practices. Okay, so to start, to get a feel of the power supply, we have our 3D printing so that we can have a look and feel in 3D to see the power supply itself. Here we have our own in-house assembly of magnetics area. So we build our own magnetics. So we wind them manually. We test them because we test our design and then we optimize. Okay, and then we have multiple design teams working on the different business units that I showed you earlier. So we bench them. So it's in a way we get our hands dirty because it's not really mostly a system level test. But we get to do soldering, we do bench work. And yes, may mga dyan, because of experimentation, we sometimes, it's part of the design. Meron dyan na maaring flaw, meron mga puputok dyan. So it's really fun, that you test your design. So, but it's part and parcel of being a design engineer. Okay, but more than that, since it's going to the market and being used by customers, we have to test them through our product safety. So no fire, no smoke, okay? So yung mga safety logos you see in the power supplies because they're tested that way, because we ensure the safety of our customers. We also ensure the EMC, or the electromagnetic compatibility of that. We are compliant to the standards, so we test for that. And we design for that. And reliability, of course, like telecom power supplies, they need to last 10 years. So they have to be reliable. So they have to be standalone right there in the pole, up to like Central European countries, up to negative 55 degrees, up to like 95 degrees base plate, kasi that's what the customer is offering us. You need to survive this 95 degrees. Okay, so we test for that. And some of the other things that it's not really being seen for digital. We now we have our own firmware development, so we do code as well. We do consistent manufacturability reviews. So not just your design is just designable in a way, quote unquote, and it just works. It has to be manufactured. It has to be repeatably manufactured. And then we do design verifications tests. So one of my principal engineers said the power supply is good as the tests you run on them. So we test, we test, we test. Okay. Then I mentioned earlier EMI, safety. And yes, the reliability, we test temperature, we test the altitude, like for telecom and 5G, about 2,000, 4,000 meters above sea level. And then we do shock and vibe, so that walang nahuhulog na mga components sa loob, and we check that. So it's really more than just paper design of things. We manufacture that. We have manufacturing facilities here too, actually in the Philippines. One is in Laguna and one is in Cavite. And one is in China. So really, it's all Philippine-based. And okay, our R&D is actually in the Philippines as well. It's in Eastwood. So we have just a snapshot of our buildings and our capabilities. So we do have our own EMC chamber there. So if you visit. Okay, this is what we do. Actually, we do these products. One of them is actually for solar. One of them is for horticultural. So we just in our booth. We are lighting a plant. And so sabi nga ng vendor, our customers, that this LED is tuned to this plant. And so we power that. We power what's inside is also not being seen. We go into these products. We go into the medical. We go into the hospital beds. We go into these MRIs. We power lights. We do EVs, solar. And of course, the server market. Okay, so so we can do this. So Facebook here is for the servers. The plants are for horticulture. And yes, buildings, lightings, etc. So these are in our website. What you can see, these are our embedded products. They go into these target applications, the one at the bottom. We are covered, from the aesthetics, really, but, before those systems are powered, we power them by highly engineered power supplies. And to get a glimpse, again, I think it's a bit over time, to get a glimpse of what we do quickly, the next one is actually a video of what we do in advanced energy. Okay, all in a day's work at Advanced Energy. So the future systems that we see now is being discussed is actually we're already in them before they're coming out. So let's power the future together with Advanced Energy, and thank you very much.
Okay. Any questions from the floor? Okay, sir. So ako na lang po magtatanong. So, tama po yung dinedesign ninyo for networks and comms na power supply. Yung that's what you mentioned earlier.
Yes, so different markets. So we go with industrial products, medical products, yes, server, networks, and telecommunications. Yeah, IT. Yeah.
Okay, so for the telco power supplies that you design, so do you actually do like system and then power supply in the loop sort of tests? Say, for example, now we want to say move into a more energy efficient telco network. So you want, I guess, more controllable and more informed power management. So do you do those kinds of?
Yes. We also work with our customers on that. If that is their platform. So we even develop tools, software that would help them, monitor power supplies or, go with the goals of their like their servers. Yeah. For telecom, since it's an emerging technology, actually they're very secretive. So even to us, they're not sharing their, let's say 5G. When it was coming out years ago, they wouldn't really share it. But we get to see the specifications that we need to do, and it's actually different from like the server platforms or any other power supply. They do have very different requirement, and they're very stringent because since nasa labas sila, they're meant to be hit by lightning, So we need to survive that. They need to be, with power line disturbances. They need to, survive ice, wind, rain, and then still last 10 years. So that's where we put our R&D on that.
Okay, thank you, Engineer Philip.
Thank you.
So, would like to present this certificate of appreciation to Engineer Philip Lagonilla for sharing their invaluable insight and work on powering the future with advanced energy during the National Electrical and Electronics and Computer Engineering Conference given this 19th day of July 2024 at Novotel, Manila, Quezon City, Philippines. Signed by our director from the UP EEI.